Alright, so let's look at question 5. Cumulative frequency curve below shows information about the times taken by 200 students to solve a Math Olympiad problem. So we have a cumulative frequency curve here on the left. On the y-axis we have our cumulative frequency, and on the x-axis we have time. Observe that the highest number on our y-axis is 200, and our frequency curve goes up to that number, and we're also told that it's 200 students who would have done the problem, right? So let's look at part A. Using the cumulative frequency curve shown above, find an estimate for the number of students who took more than 15 minutes to solve the problem. So our x-axis has minutes, so we look for 15 minutes on our x-axis, and we look for the number of students who would have scored more than 50. So we go up to our curve that corresponds to 15 minutes on our x-axis, which is going to be here, and then we have to look now for the amount of students that would have scored more than this. So that curve meets our x-axis, our y-axis, on this line here. And if we look at our scale, we have that 1 cm represents 20 units. So therefore, each one of these smaller lines here is going to represent 4 units. Why is it not writing? Yeah. So each one of these smaller lines here is going to represent 4 units. So that's 4, 8, 12, 16, and 20. So if each one of those represent 4 units, and this line is 180, here would be 184, here would be 188, here is going to be 192, and here is going to be 196. So therefore, the amount of students who would have scored more than 50 would have been this, represented by this space here, which is just 4 students. So your answer here is going to be 4 students. We're asked to find now the median time taken to solve the problem. So to find the median time, we find half of the total number of students taken, and then figure out the time for that figure. So the total number of students were 200. The total number of students were 200. Half of that is 100, so we look here. We go across to our curve here. Our curve meets our curve is met at this point here. So from 100 we go across, and it meets at this point right here. And then from there we go down to our time, and I can see that it falls somewhere in between here. So I'm going to say it's going to be 30. Alright, let's look at the scale for the bottom here, right? We have 2 cm representing 10 units on the x-axis scale. So that means that each one of these lines here represent 1 unit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it means that if this is 30, this is 31, here is going to be 32, this line is going to be 33. So I'm going to say about 33.5 minutes. 33.5 minutes. Now, if we notice where our curve was met at this point, it's not exactly on any line, it was in between. Let me erase this here. If this is our point right here. This is our point right here, and it's not exactly on the line, so it's closer to midway between this line and this line. So I'm going to estimate it at the center, right? So I took it as 33.5. 33.25 might have worked as well, but we're just gonna round it off to 33.5 minutes. Moving on, we had to find the probability that a student chosen at random took at most 28 minutes to solve the problem. So at most means no more than, right? So it means less than or equal to. So we find 28 minutes on our x-axis, which is going to fall here. So this is going to be 28. We go up to the curve that corresponds to this line here and find the number of students that would have scored less than or equal to that amount, and it's going to be 64. So it comes across on this line here and ends up there. Remember that one of these lines represents 4 units, so therefore it is going to be 64. 64 out of our 200, right? So the probability that a student chosen at random took at most 28 minutes to solve the problem would be 64. Okay, just a minute. 64 out of the 200, which is going to give us 16 over 50, or let's see, 64. Do we have the fraction symbol here, boy? Nope. 64 divided by 200. Where's the division symbol on this thing? Divided by 200. Equals 0.32 or 32 over 100. Right, so that is going to be 32 over 100, or 32%, or 0.32. Right, any of those would work. Part B, using the cumulative frequency curve on page 13, complete the table below. So the curve that we're given is a cumulative frequency curve. So we're going to have to use that information there to get our frequencies, right? Remember, the curve gives you your cumulative frequency and not your frequency, right? So for 1 to 10 minutes, we had a frequency of 12. If we look at 1 to 10, let me clean up this graph a little bit. So if we look at 1 to 10, when we come up to where 10 ends up, it ends up at 12. What's going on? Right, so that is here, and that would be 4, 8, and 12, right? And then we have to figure out from 11 to 20. So at 20 minutes, we end up there, and we end up midway between this line and this line here. This is going to be between 32 and 36. So halfway between 32 and 36 will be 34. And then we have to take away this 12 from that 34 to get the actual frequency. So 34 take away 12 is 22. So then we're going to end up here with 22 being our frequency. And then of course, we're looking for 31 to 40 and then 41 to 50. So 31 to 40 we had 84, and 41 to 50, where we ended up at 50, we ended up at, we got this before, 96. So 96 take away 84 is going to be 12. So we have 12 here again, and then we can multiply now to get our frequency by midpoint. 15.5 times 22, 15.5 times 22 equals 341. So here will be 341, and then 45.5 times 12, and that is going to be equal to 546. So we're told now to use the information in the table above Use the information in the table above to calculate an estimate of the average time taken by students to solve the problem. So basically they're asking us for the mean, and remember that your mean x bar is equal to the sum of fx all over the sum of f. We know that the sum of f is 20. Sum of fx is going to be the sum of all of this. So let's add that up. We're going to get 66 plus 341 plus 1071 plus 2982 plus 546 plus 222 equals, and this sum of fx here worked out to be 5,228. So we ended up with 5,228 over 200, and that worked out to be 26.14 minutes. Right, and that is that question 5. That's the first question on the sheet. Now, next one. A school nurse records the height each cm of each of the 150 students in the class. So this is important information. It tells you what your total frequency is. So if you need to find your mean, this is going to be your sum of f. In class A, who was vaccinated, the table below shows the information. Complete the table below and use the information to calculate an estimate of the mean height. So they want the mean height of the students and give your answer correct to one decimal place. So again, they want the mean height. To finish this table, we need to find the midpoint. So if you would notice, your midpoints are following a pattern. We have 70 plus 20 is 90, plus 20 is 110, so our next number should be 130, right? And f times x would be your frequency times your midpoint. So 67 times 130 is 8710. So this would be 8710. And like we just did just now, your mean height is x bar is equal to the sum of your fx over your sum of f, which is, now we need to sum up all of this to get your sum of fx. So that is 280 plus 1800 so that's 280 plus 1800 plus 3850 plus, what did we get for that figure? 8710, 8710 plus 3000 plus 680, 18,320. So that's 18,320. So we have 18,320 over our sum of f, which we got from before, was 150 students. So divided by 150, and we're going to get divide by 150, 122.13. So we're going to get 122 cm watching. Alright, remember they're asking for the mean height, so therefore you need to make sure that you put your units as well, okay? Alright, B, in class B, the mean height of the students is 123.5 cm, so we're given the mean height, and the standard deviation 29.87. For class A, the standard deviation is 21.38. Using the information provided on your response in A, comment on the distribution of the height of the students in both class A and class B. So basically your standard deviation tells you how far your spread is of your data from the actual mean, right? How wide does your data deviate from the mean? So for example, if you were to plot your mean, if you were to plot your data and you get a curve like this and your mean ends up somewhere here, let's call this your x bar, then your standard deviation would tell you how far apart, how wide your values fall from your mean. And if we have a higher standard deviation, 29.87, we can conclude that for class B, because we have a higher standard deviation, we can say that our height is spread out more for class B than for class A. So you're gonna have more persons on the extreme ends, or persons that may be much taller for class B than for class A. So most of your points would be closer to your mean for class A than for class B. And that's basically what you would, in a nutshell, talk about for this question. Part C, complete the cumulative frequency table below and use the information to construct the cumulative frequency curve on the grid provided on page 19. So, we know the cumulative frequency is simply adding your frequencies as you go on. So here, your cumulative frequency will be this 24 plus 35, and that is going to be equal to 59. And here it's going to be 126 plus 20, and that is going to be 146. So we now need to plot the curve on the next page. Okay, so we have some of it already plotted for us. We have the first 3 points plotted. We need to plot this one. The first point is actually the origin, or so that is not in the table. So this is the first point on the table, this is the second point on the table, and the third point which we just found, we need to plot that, right? So we're going to look for 120 on our x-axis, and then we're going to find the cumulative frequency of 59 on our y-axis. So 120 and 59, so you need to pay attention to your scale. So on our y-axis, we have that 1 cm is equal to 10 units, so it means each one of the smaller lines in between carries 2 units. So this is 50, 52, 54, 56, and 58. 59 is going to be somewhere in the center here. Right, so 20 and 59, 120 and 59, that point is going to end up right here. right there. Notice it's not on the line below or above it, it's in between the two of them, but it is on the line that represents 120 on the x-axis, right? So that's our third point. The fourth point is 140 on our x-axis. So 140 on our x-axis and 126 on the y. 140 on the x, which is here, and I can't remember, was it 26 or 126? 126. Is that one plotted for us? Yes, that one is plotted for us. And then we've got 160 and 146. 160 on our x and 146 on our y. So 160 on our x, which is here, and 146 on our y. So this line here is 140. So this is 142, 144, and 146 is going to end up right there. And that is going to be our last point, and we simply just connect the points in a nice smooth curve. Alright, so we connect the points in a nice smooth curve, and this is our cumulative frequency curve. So we are to use that cumulative frequency curve to find an estimate of the median height. So again, we find half of the cumulative frequency. If the total is 150, half is going to be 75, and that would be right in the middle of these two lines here. And that going across, that is going to meet our curve right. This curve seems a little crooked, so let me see if I can fix that. Let me see if I can fix the curve. Oh crap, I just erased all the points I plotted. Alright, I don't want to erase the points, so I'm going to erase this, and this, and this, and this, and this. Good. So now let me see if I can make that curve a little smoother. It's a bit tedious with this smooth pencil on the screen. Now it's supposed to be a continuous movement, right? But like I said, it is a little smooth. So I'm going to do my best. Okay, it's good so far. Yeah, so that'll work. Right, so halfway through 70 and 80, we're going to end up at this point right here. And if we look to read it down now, we're going to end up midway here, which is going to be, so we have to figure out our x-axis scale. We need to figure out our x-axis scale. So we have that 2 cm represents 20 units. So therefore, each one of these smaller units is going to, since it's 10 lines in between there, it's going to be 20 divided by 10, which is 2. So each one of these represents 2 units as well. So let's find our point. It is midway between here. So our point ended up here. So that is 122, 124, 125. So this mark here is going to be 125. So therefore our median height, we have to go up. Our median height is going to be 125 cm. And the probability that a student chosen at random will be taller than 130 cm. So we're going to have to find 130 cm on our curve, which is 130 would end up here. That's on our curve, it meets our curve at this point here, and we've got that is 100 there. Let me look at the question again. A student chosen at random would be taller than, so we want to get those that are taller. So those that are taller would be anything above 130 cm, so anything going in that direction. So from 100 to 150 would be 50 students, right? So that will be 50 students. 50 students out of the total. It's probability we're finding, so therefore we have to put it over the total. So it's going to be probability. How do we write this? Probability that a student would be taller than 130. Not student height. Probability, I'm going to say h for height is greater than 130 cm. Would be equal to, it was 50 students over 150, and that is going to be 0.33 or 1/3 or 33.3%. Okay, let's see, same kind of question. We're given a cumulative frequency curve, and we're asked how many students walked at most 1 kilometer. So at most means no more than, so we're looking at those less than or equal to 1 kilometer. So we find one, find the position on the curve that matches with 1, and determine how much students is represented by that space there to get those that walk for less than or equal to 1 kilometer. Using the cumulative frequency curve, we can determine an estimate of the median, so we know how to do that. For the median, again, we find half of it, which is going to be 60. Come over to your curve at this point and read off the value that is going to be here, right? So we need to figure out our scale. 2 cm equals 0.5 kilometers. So we've got 2 cm being equal to 0.5 kilometers on our x-axis. So then each one of these would be 0.5 over 10, which is 0.05, right? Because we have 10 lines in between there, we divide up that 0.5 by 10, and we will get what each line represents. So if that's 0.05, then here would be 1.05, here will be 1.1, here will be 1.15, here will be 1.2, here will be 1.25, and this is going to be 1.3. So therefore our median is going to be 1.3 kilometers. For our lower quartile, is basically half of the number of students that we got for our median. So we basically break up our, instead of half like what we did for our median, we break up our curve into quarters. So half of 60 is 30, which is going to be here, and then we're going to read off this value here, which would be, so here will be 0.5, 0.55, 0.1, 0.15, 0.2, 0.25, 0.3, 0.35. Oh, 0.5 divided by 10 is 0.05. right? So each one is represent 0.05. So why is this not adding up? Oh, sorry, my bad. Here would be 0.5, 0.55, 0.6, 0.65, 0.7, 0.75, 0.8, 0.85, and 0.9. So this is 0.9. This is 0.9. So therefore our lower quartile is 0.9. Our interquartile range is your upper quartile minus your lower quartile. So let's figure out what our upper quartile is. So to get the lower quartile, we broke up the bottom half. The bottom half of our curve, we split that in half. To get the upper quartile, we're going to split our top half of our curve into half. So therefore, between 60 and 120, halfway there is going to be 90, which is going to be there. We find the corresponding spot on our x-axis, which would be here, and that is going to be 1.55. So our upper quartile is 1.55, right? So your interquartile range is your upper quartile minus your lower quartile. Which is going to be 1.55, take away 0.9, which is equal to 1.55 minus 0.9 equals 0.65. So that's 0.65. That's going to be our lower quartile. C. A student is chosen at random. What is the probability that a student walks for more than 1.5 kilometers to school that day? So we find 1.5, go up to the curve, figure out how many students walked more than that. So 1.5 is here. Our curve meets at this point. So, and that is going to be 82. So this is 82. So how much walked more than that? We had 150 students in all. So, sorry, 120, take away 82. That is 38 students. So we had for our probability, what is T? Let's look at the probability of D. The distance is D, right? So your probability that D is greater than 1.5 kilometers would be 38 over 120. So 38 divided by 120 equals 0.32. So we're going to round off, right? 38 divided by 120 equal. We're going to round off to 2 decimal places. So therefore, we're going to have 0.32. So that's going to be 32 over 100 or 0.32 or 32. 32%. 32%. So that is that. And D, complete the table below. Use the information to calculate an estimate of the mean. So we have to find the midpoint, 0.25, 0.75, 1.25. Follow the pattern. This will be 1.75. We find our number of students in the same way that we did in the last question. So we look for 2 on our curve. Read out the value and take away 46 from that. So for 2, we have 2 giving us this here. So that's going to be 110, 112. Wow. 112. And the last one is 1.5, right? So let's look at what 1.5 is as well. 1.5 gave us 82. So 112, take away 82. So that's going to be 112, take away 82. And that's going to be what, 30? 30. Alright, so let me make sure. 112 minus 82 equals 30. Yeah. So we do the same thing for the next one. We know that at 2 we have 112. Let's see what we have at 2.5. So 2.5, we've got 118 students. So 118 take away 112. It's going to be 118 take away 112, and that is going to give us 6 students. Now we can multiply, get our f times x. 1.75 times 30. That's 52.5. And then 2.25 times 6. And that is 13.5. So I'm guessing we're going to be asked to get the mean. Yeah, right? So we know we're going to need our sum of f of x. Sum of fx, not f of x, sum of fx. And that is going to be 3 plus 18 plus 57.5 plus 52.5 plus 13.5 plus 5.5. That works out to be 150. Right? And we know that our sum of f was 120. We saw that from the graph, right? The highest number that is plotted on the graph was 120. So we know that our total frequency was 120. So working out our mean, x bar is equal to sum of fx over the sum of f, which is 150 over 120, and that is going to be 150 divided by 120 equals 1.25. So we got 1.25 kilometers. So your mean is always based on whatever you were measuring. In this case, it's distance. So please, that is the unit you're going to put for your response, right? Notice they ask you for the mean distance. So therefore, you're going to be putting your units accordingly. And that is the last question I'm going to do for question 5. You'll basically have an idea of all the things that may come with respect to cumulative frequency. For this question, I see they're asking for modal class. 100 students were surveyed on the amount of money they spent on data for their cell phones during a week. The table below shows results as well as the midpoint for each class interval. Using the table, determine the modal class of the amount of money spent. So of course the modal class would be one that has the highest frequency. In this case, your highest frequency is 31. So therefore your modal class is this class, right? So it's going to be 70 less than x less than or equal to 80. It's going to be your modal class. Estimate of the mean. amount of money spent, give your answer corrected 2 decimal places. So you're going to have to find your f times x and then get your sum of fx, and this here is going to give you your sum of f, and you use the formula that we used above to get your mean, where x bar is equal to sum of fx over sum of f. So you can work that out. Damien reports that the median amount spent is 84. Briefly explain why Damien's report could be correct. I probably have to work out the mean to get the answer for this, but I'm not going to work out the mean, so I'll leave that up to you. The two-way contingency table below gives information on the mode of transportation to school for 100 students. Complete the table by inserting the missing values, right? So notice that we have a total here, so it's just a matter of subtracting. So this is going to be 23 take away 15, and that is going to give us 8. Here we have, we can figure out this because this total, so how your contingency table works, you have a grand total here, right? And this total, this grand total totals everything in this column or everything in this row. So therefore, if you just, once you have the grand total and you have this and this, you can figure out what this is. So 40 add 23 is going to be 63. So we're going to have a difference of 100. Here will be 100 minus 40 add 23, which is equal to 100 minus 63. And that is going to give us what? 37. 37. Now that we have the total here, we can figure out what our boy figure is for a cycle, and that is going to be 37 minus 18, which is going to be 17 take away 8 is 9, so that's going to be 19 here. And of course 100 take away 48, take away 48 is 52. So table completed. A student is selected at random. What is the probability that he or she was being driven to school that day? So we're looking at the total number of students being driven. So we look at the total being driven against the grand total. So that is going to be 40 over 100, which is 0.4. So boy or girl, they didn't ask whether it's a boy being driven or a girl being driven. They just asked some student taken at random, and they wanted the probability that that student is going to be driven. And in total, we had 40 students being driven. Out of the 100, we had 40. So the probability is going to be 0.4. One of the girls is selected at random. What is the probability that she did not cycle to school? So did not cycle to school means that she either walked or drove, and it is a girl, right? So the probability that she did not cycle to school will be the probability that she walked, that the girl walked, plus the probability that the girl drove, right? So it's going to be the probability of walking plus the probability of her driving to school, and it's a girl. So the probability that a girl walked would be 8 out of 23. Plus the probability that a girl drove, 26 out of 40. So that is 8 divided by 23 plus 26 divided by 40. Divided by 40. Close my brackets. That equals 0.997. and that worked out to be 0.997. Was it 7 or 8? Let me check again. 0.998, sorry. 0.998. Alright, so we'll stop there with question 5.